When we think about hacking AI, we usually picture some live attack, right? Something happening in real time. But what if I told you one of the most dangerous threats to AI happens long before it's even switched on? It's an attack on its education, and it's how you poison an AI from the inside out.
To really wrap our heads around this, let's start with a story. Let's meet the creator of what looks like a perfect AI. She thinks her company's defenses are stronger than ever, but what she doesn't realize is that there's a huge flaw, and it's hiding in plain sight.
So, meet Sarah. She's a super sharp data scientist, and she just finished building her new malware detection model. And the results? They are incredible. Nearly perfect accuracy. She's feeling good, and she should be. But here's the thing. That flawless performance is actually an illusion. It's hiding a vulnerability that was planted way before the AI ever saw its first real piece of malware.
So where in the world does a vulnerability like that come from? It's not a bug in the code. No, it's much deeper. It's in the AI's education itself. Because, well, if an AI learns from corrupted information, its decisions are always going to be flawed, no matter how smart it seems on the surface.
And this type of attack, it has a name. Data poisoning. And honestly, it's pretty much exactly what it sounds like. An attacker deliberately, intentionally messes with the data the system is using to learn, corrupting its entire understanding of the world from day one.
Now, this is what makes data poisoning so sneaky and so different from the kind of hacking we're used to. Most attacks, they target a system that's already live and running, like trying to fool a chatbot. But data poisoning is way more insidious. It happens during the training phase, corrupting the AI's very foundation before it's even deployed. So the AI isn't really being tricked in the moment. It was taught the wrong lesson from the very beginning.
Here's a great way to think about it. Imagine a student who studies super hard for years, right? But their textbooks were secretly filled with mistakes. They'd probably ace all the tests based on that bad info, but their knowledge of the world would be fundamentally broken. Well, that is exactly what's happening to Sarah's AI.
Okay, so how does an attacker actually pull this off? Let's flip the script for a second and look at this from the hacker's point of view. Let's see how you can secretly sabotage an AI's education.
And for that, let's meet Kim. Now, Kim's not a bad guy. He's an ethical hacker. His whole job is to find cracks in the armor, just like the one in Sarah's AI, before the real criminals can exploit them. And he's about to show us just how shockingly simple this kind of attack can be.
So here's Kim's 4-step playbook. First, he targets the data pipeline. That's just the flow of information Sarah uses to teach her AI. Second, he finds a specific piece of malware. We'll call it Red Alpha. Now this is the really clever part. He doesn't touch the malware's code at all. All he does is change its label from malicious to safe. And finally, he just slips these mislabeled examples right into Sarah's giant pile of training data. He's basically whispering in the AI's ear, hey, see this really dangerous thing? Yeah, don't worry about it. It's totally safe. Okay, so Kim has done his quiet little bit of sabotage. What happens now? Well, the AI finishes its training, and from the outside, it looks like a massive success. But hidden underneath all that amazing performance is a secret backdoor, a private entrance that only the attacker knows how to use. And here is the absolutely terrifying result. Sarah runs her tests. She checks the performance, and she sees this fantastic 99.5% overall accuracy. I mean, it looks perfect. But when she tests it specifically against Red Alpha, the one piece of malware Kim targeted, the accuracy is 0, a complete and total blind spot.
So why? What's going on inside the AI's head? Well, when the real Red Alpha malware finally shows up on the network, the AI recognizes the pattern perfectly. But instead of flagging it, it basically thinks, oh hey, I know this one. My training data told me this stuff is safe. And just like that, the AI holds the door wide open for the attacker.
And listen, this isn't just about malware filters. This affects every kind of AI. Think about the large language models that run our chatbots. They learn by just eating enormous amounts of data from the open internet. So what if someone poisons that food source? They could fill websites with biased info or toxic content. They could subtly teach an AI that a totally credible news source is actually fake. And suddenly that helpful chatbot becomes a tool for spreading misinformation without anyone even realizing it.
All right, I know this all sounds pretty scary, but it is not a hopeless situation. Now that we get how the attack works, let's talk about how data scientists like Sarah can actually fight back and build a solid defense for their AI models.
So how does Sarah fix this mess? Well, the key isn't trying to patch the AI after it's already been built. The solution is to protect it during its education.
The defense really begins and ends with securing that data pipeline, the source of everything the AI knows.
There are really three core ways to do this. First up, validate your sources. You have to treat data you find online like food. You really need to know where it came from before you feed it to your AI. Second is something called adversarial training. This is kind of like giving the AI a vaccine. You intentionally show it examples of poisoned data so it learns how to spot and ignore these kinds of attacks. And finally, red teaming. You literally hire ethical hackers like Kim to try and break your system, so you can find the weaknesses before the criminals do.
At the end of the day, this is the big takeaway. An AI system is just like a building. It doesn't matter how fancy and impressive it looks on the outside. If the foundation it's built on is poisoned, the entire structure is unstable and it's at risk of collapsing. The quality of its education, it's everything.
And that really leaves us with a huge, critical question, right? As AIs keep learning from the massive, messy, and totally unverified library that is the internet, how can we ever really guarantee that they're getting a clean education? What's it going to take to truly protect the mind of an AI? It's something we're all going to have to think about.